Hi, my name is Guillaume Goutelier. I am an enterprise architect at AWS. Today I want to show you how you can use the Amazon Managed Blockchain Service to interact with the Bitcoin network. In the following demo, I will record some data on the Bitcoin testnet. I will use some random data, but you could record more meaningful data if you want, such as the identifier of an IPFS file. If you want to know how you can run IPFS on AWS, you can refer to some of the links in the description of this video. If you want to follow along, the only thing you need is a web browser connected to your AWS account. Let's get started. From the AWS console, select a region where the Amazon Managed Blockchain Service is available, such as US East 1. Then start the AWS Cloud Shell. We will maximize the Cloud Shell window so it's easier to work on it. Let's start by installing some prerequisites. We will use AWS curl to interact with the Amazon Managed Blockchain Service, so we need to install this tool first. We can use the sample command from the documentation to check that AWS curl can connect to the Bitcoin Access Service endpoint. Multiple libraries exist in different programming languages to manipulate Bitcoin transactions. In this demo, we will use the Bitcoin.js lib JavaScript library to generate the Bitcoin transactions, but it would be possible to use another programming language or library. We're all set. Let's start the Node console and generate a new Bitcoin key pair. To do that, we use the key management functions of the cpair library. In a production environment, you may want to use a key management system like AWS KMS to handle your keys. But for the purpose of this demo, we will simply backup the key pair in a wallet import format. Let's write down this value and check that we can re-import the key pair. We will use the post-SegWit address format and script for the transactions. So let's extract the pay-to-witness public key hash and corresponding address from our key pair. We can write down this address. We will not be able to do much until we get some test bitcoins, or test satoshis to be more precise. To do that, we will request funds from the coinfaucet.eu website. But feel free to use any faucet of your choice. The faucet has sent us this amount of satoshis. Let's go to a Bitcoin testnet explorer, such as the one from Blockstream, and enter our Bitcoin address. We see one transaction that relates to our address. Bitcoin chooses an unspent transaction output or UTXO model, where the outputs of past transactions are used as inputs to the new ones. To prepare future transactions from our Bitcoin address, we need to record the transaction ID of the initial funding transaction, the index of the output, and the exact number of satoshis that we received. Let's go back to Cloud Shell and record those values. We now have all we need to create our transaction. To do that, we will use the PSBT object from the Bitcoin.js library. PSBT stands for Partially Signed Bitcoin Transactions. This is the community standard that is used to craft Bitcoin transactions. As mentioned earlier, we need to reference the output of a previous transaction as an input to our transaction. We can conveniently get this output from the pay-to-witness public key hash of our key pair. If this sounds a bit obscure to you, there is a link in the description providing more information on Bitcoin scripts. Let's now create the input part of our transaction using the different pieces of information previously collected. We will have two outputs in the transaction. An up-return output with 0 value to record some data, and another output to send us back some satoshis. The difference between the satoshis sent back to us and the satoshis from the input constitutes the fees of the transaction. Let's start with the op-return output. We start by defining the data that we want to record. For this demo, I will use a small text, but it can be anything shorter than 80 bytes. So again, you could store an IPFS content identifier if you want. We can conveniently use the payments.embed function to create the op-return script. For the second output, we first compute our change. Then we use this value and the pay-to-witness public key hash address to create the second output. Here, we are using the previously generated address, but we could have created a new one for increased privacy. Let's now sign the transaction. We use the signInput function from the PSBT object with the index of the input we want to sign and our key pair. We have a unique input in this transaction, so we can now call the finalizeAllInputs function. That's it. We can now extract our transaction in raw format so we can later broadcast it on the Bitcoin network. To broadcast the transaction using the Amazon Managed Blockchain Access Bitcoin service, we will use an AWS curl command similar to the one we previously used. Except we will use the sendRawTransaction method, the raw transaction as parameter, and the testnet endpoint. This command returns the transaction ID. We can use this transaction ID to double-check on the Blockchain Explorer whether it has been successfully included into the Bitcoin blockchain. If we inspect the transaction, we see that it contains two outputs. An unspent output that we will be able to use for future transactions, and an op-return output that contains the data we wanted to record. That's all I wanted to show you today on this video. Thanks for watching.